Hello everyone. In this video we will understand the fundamentals of antennas, antenna arrays and beam. Okay. This is a basic video. The advanced level of this will be discussed in the respective channels. So let's start with antenna elements. Antenna element. Okay, this is like the antenna itself. Okay, anything maybe a device or a circuit that converts electric signals to electromagnetic waves is an antenna element. Okay, basically something that radiates the electromagnetic waves, okay, of some configured frequency. Okay, so it's basically a component that independently radiates. Okay, so this is an antenna element. When an antenna radiates, okay, it radiates like a light bulb. Okay, this light bulb that we have seen. Okay, so it will radiate in all direction. Okay, forming a three-dimension beam like this. Okay, both horizontally and vertically it will form a beam. Okay, let's say if I am showing horizontally like this, then vertically, so maybe like this. Okay, this is about a single antenna element. Okay, now you should also know about antenna polarization. Okay, as we know, the electromagnetic wave has electric and magnetic field orthogonal to each other. Okay, so it also depends on how you place the antenna. Okay, whether the antenna is placed horizontally or vertically. Okay, this is vertically placed, this is horizontally placed. Okay, so in both the cases, okay, the electric field plane will be different. Okay, so in both the cases, like in vertical and horizontal, the electric field will be orthogonal to each other, and this property can be utilized to place two antennas together having orthogonal electric field with each other. Okay, so this is antenna 1, this is antenna 2. Okay, this is called dual polarization. Dual polarization. This is single polarization. Okay, we can utilize, and we can, in a small space you can have two antennas placed together. Okay, this gives more gain. Now it also depends how these two antennas together placed compared to the ground level. Okay, this is the ground level. Now there are two different ways that we are going to discuss. One is this, okay, where one antenna is perpendicular to the ground, okay, and the second one is parallel to the ground. Other ways like this cross. Okay, in this case, in the second case, both the antennas are symmetrical to the ground level. Okay, so if you compare case 1 versus case 2, basically these two orientations, okay, what we have seen is this case 2 gives symmetrical performance, it gives uniform coverage and less cross polarization interference compared to the case 1. Okay, so we always place the dual polarized antennas like this, like case 2. And this is why you have always seen in different literatures antennas are displayed like cross. Okay, basically there are two antennas, okay, dual polarized and placed like this. Okay, now let's understand what is antenna array. Okay, so if antenna array is nothing but a group of antennas placed together. Okay, these are four antenna elements placed together, or we can display them like this or like this if there are two elements. Okay, this is called antenna array. Okay, now let's understand what happens when you place two antennas together. As we have seen, if you have one antenna element here, okay, the beam is like this. It's a wide beam, okay, in both horizontal and vertical direction. Okay, what happens if I add one more antenna element here? Okay, so okay, the beam will be narrower compared to the previous one with the single antenna element. Okay, it became narrow. Okay, and it's more directional, as you see this. Okay, so approximately 3 dB gain will be there, 3 dB directional gain will be there, and it will shrink 3 dB in the direction which antennas are placed. So if they are placed on a vertical direction, okay, the beam will become narrow in the vertical direction. This is because how the two different electromagnetic waves will add up. Okay, consider this example. We'll just discuss this in brief. Okay, let's consider this point. Okay, so two waves coming from these two elements, since these points is at the same distance, let's say distance d, okay, from both the elements. Okay, so they will constructively add. Okay, and now let's say you have a point somewhere here. Okay, this distance is, let's say, d1. Okay, if d1 is lambda by 2, that we normally have. Okay, this wave will add like this, and it will be zero energy here. Okay, they will be destructively add, will be zero energy. Okay, so this way, if the point is here, 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 okay, so it will be, if we can calculate at different points as well, what we'll get to know is, okay, in the vertical direction, okay, there will be more energy in this direction, okay, at the center. Okay, given that both the antennas are fed with same signal. Okay, where in the horizontal plane, okay, it will still be a wide beam. Okay, in the horizontal it will still be a wide beam, but in vertical it will become narrower. This is because we put two elements in the vertical direction. Okay, what happens, so it will be, maybe I'll display it again. Okay, so these two elements, okay, it will become, okay, maybe it will be narrower in this direction, okay, where in the horizontal direction it will be wider. Okay, it's difficult to draw a 3D beam here. Okay, now what happens if you put two antenna elements on a horizontal plane? Okay, then the beam will be narrower on the horizontal side. It could be like this, or it could be maybe let me just draw like this. Okay, where on the vertical it will still be a wide beam. Okay, so the more the antenna elements we add, okay, if we add instead of 2, if we add 4 antenna elements in vertical, let's say, the beam will become narrower, okay, and more directional. Okay, this is on with 4 antenna elements, and let's say this was with 1 antenna element, and this was with 2 antenna elements. So this is with 1, this is with 2, and this is with 4. So this is how the more the antenna elements we add, okay, the more direction the beam will become, okay, and the more narrower it will be in the plane, okay, in which the antenna elements being placed. Okay, now let's understand the different combinations of how we connect the antenna elements, okay, and how it plays a role. Okay, so let's take this. Okay, how many antenna elements are there? 4 plus 4, total 8 antenna elements. As you see, these 4 and these 4. Okay, there are total 8 elements. So what happens if we feed the same data to all? So I'll consider only 4 at a time. So let's say we take these 4 antenna elements and we fed the same data to all of them. Okay, as we have seen just now, there will be a narrower beam like this. Okay, now this is case 1, case 2. Okay, what happens if we excite all antenna elements, okay, with different data, okay, different streams we can say. Okay, so then with each antenna element, okay, there will be a wide beam. This is correspond to antenna element 1, then same with antenna element 2, same with antenna element 3 and 4. Okay, each of them have different data. Of course, the same is applicable to the other polarization as well, but for now we are discussing only single polarization. Okay, to not to complicate the examples. Okay, so since we are feeding different data, different stream, corresponding to each stream there will be a wide beam vertically, and here since we are feeding the same data, okay, there will be a single narrow beam on the vertical plane. Of course, horizontally the beam will be wide. Okay, now let's take case 3. Okay, let's say we form a group of 2. these two we form and we get the same data, and let's say these two we feed a different form of data. Okay, then what happens? Okay, with these two there will be of course a beam. The beam won't be wider as single antenna, it will be narrower since there are two antenna elements now. Okay, so the beam will be like this. Okay, somewhat directional because there are two antennas. Okay, and somewhat narrower. Okay, the same with the remaining two antenna elements as well. There will be another beam corresponding to this input. Okay, so two narrow beams in this case. Let's take case 4. Okay, let's say we have again two groups. Okay, and here also group of two. Let me add a different color. Okay, but we give a phase shift to each of them. Okay, this is 45 degree plus, and this is, let's say, minus 45 degree. In this case also again the same, there will be two beams. Okay, narrow beams, but there will be directional beams like this, one beam, and other beam like this. Okay, so again two beams vertically separated. Horizontally still there will be a wider beam, okay, with the same coverage, but vertically beams will be separated. So let me show this nicely here. So these antennas are placed like this. So this case is like, let's say we have one beam covering this area. Okay, one beam covering this area. Okay, based on the phase shift we directed both the beams, okay, vertically covering, this is ground. Okay, one is covering this area, the people and homes here, and other is covering these buildings here. Okay, but horizontally the beams will still be wider. Okay, let's take fifth case. Okay, let's say we have same data to all four, but with a phase shift, each with a phase shift. Okay, in this case the same, there will be narrow beam like the case 1. Okay, since all four elements have same data, it will be a narrow beam, but since we are giving phase shift, it will be a directional beam. Okay, we can orient it based on the phase given here. The beam will be directional, so it could be like this. Okay, narrow beam and pointing to some other direction based on the phase shift. Okay, so this is about the orientation. Okay, now how we are giving this phase shift? Okay, can have, I mean, the way we are giving the phase shifts can be divided into different parts as digitally giving phase shift, or you can call digital beamforming, or analog beamforming, or hybrid. Okay, how do we understand three of them? Let's go over them briefly. Digitally means, okay, first let's say analog. Okay, this is our Digital, these are all digital signals, basically baseband. Okay, and like we have just seen similar diagrams, these are fixed phase shifts given. Okay, these are 4 antennas and these are phase shift, and this is RF chain. Okay, this case, because since there are less number of RF chains, okay, this analog beamforming is low cost solution, but it's limited. Okay, we cannot have multiple streams. Okay, we cannot have, like we have more number of data streams going, each going to different antennas. Okay, that kind of control we don't have. Okay, we can't steer the beam however we want. Okay, that particular case is gone. Okay, but in case of digital, okay, these are digital or baseband signals. Okay, and they are directly connected to antennas. So the phase shift is given digitally. Digital phase shift is given. Okay, so this way we can independently control each antenna element here. Okay, we can have desired direction, we can have multiple streams. Okay, but the problem is this part is costly because we have multiple RF chains. Okay, this is a costly solution. Think about millimeter wave. In that case, where we have 256 antenna elements, 64 antenna elements, okay, and having a dedicated RF chain for each of them is a very costly solution. So what is hybrid beamforming? Okay, in hybrid beamforming we have both digital, okay, and analog. Okay, say phase shifters. Okay, or you can also call it digital precoding or beamforming and analog precoding. Okay, like for example, from the previous example only, let's say that these are RF chains. Let's say one of the solution is like this, where you have phase shifts as well. Okay, this is the analog part and also controlled digitally here, and this is analog. One of the complicated way is that we also have practically as well, that from this digital precoder, okay, we are considering the 4 antenna case. Okay, each of the chain is connected to each of the antenna elements. Okay, so with this similarly for this, each chain is connected to each antenna element to have better control. Okay, this becomes very messy and complicated. Similarly the fourth chain. Okay, this is both are this one and this solution where we have digital and analog both precoders. Okay, or we have the control from the digital and analog both. This is called hybrid. It's called hybrid beamforming. Okay, now let's go and understand that the practically what we have nowadays in 5G. Okay, this is a particular example of the antennas that we have currently installed. Okay, this is okay like a, this is how an 88R solution looks like. Okay, this solution, okay, as you see there are 8 RF chains here. One is this, third one and fourth one. The 4 you see, and you see both are dual polarized. Okay, so there are 2 here, 2 here, 2 here and 2. So there are total 8 RF ports, total 8 antennas. So it's known as called as 88R okay solution. Okay, and this is how the practically looks like. Now as you might question that, okay, why we mostly have antennas arranged vertically, like you see here also. This is how practically antenna looks like, where the mostly the antenna elements are placed vertically, is because, like, let's say this is our antenna, okay, and the antenna elements are placed like this. Okay. This is because first we have a down tilt. Okay, this is from a plane. Okay, we have a down tilt of, let's say, 2-3 degree. Okay, so that the orientation is towards the ground. Okay, now let's say this is the ground level, and this is how we have different buildings, people living here and all. Okay, so horizontally we mostly want this antenna to give coverage to full, let's say 120 degree, 60 degree, or whatever we have planned. Okay, but vertically we mostly want it to be directional, okay, and points towards the ground. Okay, this depends on, okay, whether we want to focus on maybe, let's say, 1 kilometer, 5 kilometer, that area, or let's say we have multiple beams, then we want to have one beam like this focusing little far, and then one beam is like this, and one beam like this. Okay, we don't want this antenna to radiate on top. Okay, so we mostly don't want to have vertically 120 degree beam, but horizontally we want it to serve all the users around it. Okay, that's one of the reason we have the antenna elements arranged like this. Okay, now let's see the recent antenna arrangements. Okay, so let's look at this one of the example. Okay, as you see there are 8 antenna elements placed vertically. Okay, 8 rows and 4 columns. So in total we have 8 multiplied by 4 and dual polarized, total 64 antenna elements. Okay, in total. Okay, there are 2 antenna elements dual polarized. Okay, so let's consider case by case. Case 1. Okay, case 1 is when each column is connected with single input. Okay, like this. So this is input 2, this is input 1, and let's take one more case. This is the dual polarized part. This is okay, so I will call this second and this third. Okay, similarly 4th, 5, 6, 7, 8. Okay, so in this case each column is connected with single input. Okay, so this kind of arrangement is called 88R system. Okay, and now we have seen this. If the antennas are arranged vertically, it will have vertical narrow beams. So since there are 8 antennas, there will be a narrow beam vertically. Okay, and since there are 8 vertical antennas, so there will be total 8 beams vertically. Okay, now it depends on how the phase shift is given, how the digital or analog recording is being done. Based on that, okay, the direction of the beam will change. The beam could be like this, the beam could be like this, but in total there will be 8 vertical beams. Okay, and all of the beams will be horizontally wide. Okay, all the beams will be wide horizontally. Okay, let's take another case, case 2. In this case, let's say we group the antennas in 4. This is one group, in the sense these 4 antennas connected with one type of input. Let's say these 4 antennas connected with second input, and let's say these 4 connected with third, and these 4 connected with fourth. Similarly, all a group of 4 antennas are grouped together and connected to have a single input given. Okay, so in total, as you see, 2 antennas here, so 2, 8 here and 8 here, total 16. Okay, so total we have 16 antennas. So it's a 16 antennas with 64 antenna elements. So this system is 16TR, 16T, 16R. Okay, in this case, how the beam will be formed? Okay, since still as you see the antennas are placed vertically. Okay, so there will be a vertical beam comparatively wider than the previous one, because in previous case we had 8 vertical antennas. In this case we have 4 vertical antennas, so the beam will be comparatively wider from the previous case, but there will be 16 vertical beams, and the direction of the beam will depend on the phase given to each input. Okay, the beam, there will be 16 beams horizontally. Still there will be, all the beams will be wider. Okay, so horizontally wider beam, all the beams will have the same, let's say if it is 120 degree, all the beams will cover same 120 degree, vertically narrow beam. Okay, let's take another case. Let's take this. Okay, in this case, let's say we group these 4 together. Okay, 4 columns, 4 rows. Okay, having all of them same input. Okay, so all 16 antennas are connected to a single input. Okay, and the remaining 16 are connected to another input. Of course, the other part, because it's a dual polarized. Okay, the other one connected to a different input, that is always there. Okay, and here also. Okay, So in total we have 4 different you can say RF chains going in, or 4 different data streams going in. So this is called a 44R system with 64 antenna elements. Okay, now let's see how the beam looks like. Okay, so since this time we are putting, or the input is given to 4 horizontal antennas and 4 vertical antennas together. Okay, in total there are 4 rows and 4 columns. Okay, so the beam will be narrower horizontally and vertically both. Okay, so the beam will be like this, horizontally and vertically both direction it will be narrower. Okay, same for this, the beam will be narrower horizontally and vertically, and this way you can have this beam focused to a different UE placed at a different location. If there is a UE here and there is a UE here, so in this case horizontally, if it is in the other side of the antenna, the beam can be oriented like this. Okay, where for this UE it can be like this. Okay, so in this case you have horizontally narrower beam, vertically narrower beam. Okay, in total 44R with 64 antenna elements. So this is the basics about antennas and beams in 5G. Okay, we will understand these concepts more in detail in the respective channels. Thank you.